Well, hello Internet and welcome to my Rust video tutorial. In this tutorial, I'm going to provide an introduction to the core syntax of the Rust language because I've received numerous questions about it. Now, unlike my normal Learn in One videos, instead I'm going to focus in on the specifics of the language so that you have a really good understanding of how it works. And also I'm going to cover a lot of the things that confuse beginners so that then you can then move on to books and other resources online that you may find. Now, a link to all of the code as well as a transcript from this video is available in the description underneath the video. And what I'm going to focus in here on is I'm going to talk about input, output, variables, math, conditionals, looping, strings, arrays, vectors, tuples, functions, closures, pointers, structs, traits, enums, and a whole bunch more. And I have a lot to do, so let's get into it. Okay, so if you are on Windows, what you're going to do is go to rust-lang.org and click on Downloads. And if you have a GNU C++ compiler on your computer, you're going to use this version. And if you have a Microsoft Visual C version of C++, you're going to use that version. And basically just click on that, click Next a whole bunch of times, and there you go. You're ready to use Rust on your computer. And everything else in this tutorial is going to work on Macs as well as on Linux and also Windows machines. Now, if you are on a Mac or Linux-based machine, you're going to install Rust more than likely like this. You're just going to copy and paste this line of text directly inside of your terminal and then hit enter, and that is going to install Rust for you. And of course, like I said, I have this in the description so you can just copy and paste to make sure you get that installed properly. And I'm going to be using the Atom text editor here to edit. It's free and it's exactly the same on every operating system, so that's why I'm using it. And I want to show you how you can come in here and install a package that's going to make it easy for you to use Rust. You're just going to go Packages, Command Palette, and Toggle. Install inside of here, and you're going to click on Install Packages and Themes. And then inside of this guy, you're going to type in Atom-language-Rust and hit enter. And you're going to see that Atom Language Rust shows up here, and there's going to be a little install button. Just click on that and it will be installed, and then you'll be able to easily program Rust applications inside of Atom. Alright, so now that we have that set up, let's start writing some code. Now, the very first thing that I'm going to do is come in here and install a module that's going to allow me to show you more about data types and how they work inside of Rust. And you can see all the different data types that are available to us. And I'm just going to put a semicolon here in the end, and I'm going to soft wrap that so you can see all the code there on the screen at one time. I'm also going to install another module that's going to allow us to receive input from our users. And that's just standard in. Now, the main function is going to be the main function that executes whenever you execute your program. And how you create that is just go fn and main, and that's how you create all functions inside of Rust. And then we're going to come in here and just do a simple hello world type of example because we have to always do that, and save that. And then you're going to come over here and you're going to compile. And I like to get rid of all the warnings because if you don't do this, you're going to get warnings for every single thing, and that's not going to work. So how you compile is just go rustc and the name of your Rust application with rs for the extension and a and warnings. And then after that's compiled, you can run the application and you can see that hello world printed out there on our screen. We're going to use let to define all of our variables, and the data type will be guessed if you do not provide it. And it's very important to know that variable values by default are immutable inside of Rust, which means that those values can't be changed once they're set. So let's just go and create one and have the Rust compiler go and automatically figure out what type of data type that is. That's just a basic integer. You could, of course, come in here and not only make a variable that is mutable, which means that the value can change, but you can also come in and define the data type for that value or for that variable. And I showed you before all the different primitive data types that you have inside of Rust. There's just a list. These are integers, 8-bit, 16-bit, 32. This is going to be an integer based off the buffer size on your computer. This is going to be unsigned. This is going to be a 32-bit float, which just means a number with a decimal place. And we'll be using all of those as this continues. And just so you know what sizes you can keep in all these different data types, I'm going to come in here and go print line. And if we want to get to the maximum number we can store in an 8-bit integer, we just go like this with max at the end, and this value is going to be transposed right here between these two curly brackets. If we compile and execute that, you can see those numbers are quite large, so let's zoom out here. Max 8-bit integer, and that's 127, negative 128 is the minimum, and you can see so forth and so on how big these numbers get inside of Rust. So that's just a basic idea of the types and how large those different data types can be inside of Rust. We're also not only going to be able to use those different data types, we're also going to be able to use booleans. So we can do something like, is it true? And say that we want this to be a boolean, and we can either store true or false inside of booleans, of course. We're also going to be able to store individual characters. So let's say I wanted to store the letter X inside of here. I can define that that's a character, and that is going to have the value of X, of course. And like I said before, we're able to place variables inside of our output, just like you saw previously, by just going I am and throw curly brackets inside of there, years old, and then right here we're going to be able to go age and get that value right there. And there you can see hello world came back and I am 40 years old, and with age transposed directly inside of the output. Another thing that's important to know is we'll actually be able to set the values for multiple different values or variables inside of Rust, and also the variable names are going to start with letters, and they're going to be able to contain letters and underscores. And normally these variables are going to be separated with an underscore. That's common practice. You'll actually get an error if you don't do that. And I can come in here and assign two variable values just like that. So there's a brief overview of variables. We'll be doing more with them. Now I want to focus in on some other ways you can output your data. Now you're going to be able to place multiple different pieces of information and in different ways inside of Rust. So let's come in here and do something like it is curly brackets, throw a 0 inside of there, that, curly brackets again, is, and throw that 0 there, and then we'll throw is it true inside of there, and let X, and we'll go and get those variables and variables and throw those back in there. And then we're going to be able to run that, and you're going to see right here, it is true, and it got that true value from this guy right here, and then it also used true right there. So we're able to use indexes to load the different data over and over again for our output. We're also going to be able to output or change our output in multiple different ways. So let's come in here and let's say that we want only 2 decimal places to show up for data that we want to output on our screen. We could do 1.234 and provide 3 and just get 2 in exchange. Now let's go into a couple other different things here. We're also going to be able to output binary, hexadecimal, and float information. Just go binary, and :B is going to get our binary data output, and hexadecimal is going to, if we throw a lowercase x, it's going to provide lowercase hexadecimal numbers, and then octal as well, or base 8, and we'll just do lowercase there, and we'll get the value for 10 in these different number bases. And there you can see exactly how those all print out right there. In regards to other ways we can edit or format our output, we're also going to be able to use named arguments as well as define white space with our data. So let's come in here, and inside the curly brackets, of course, we can put a named argument inside of here, and then we can define how much white space we want to put inside of there, and then outside of here define our named arguments with our white space. And also we'd be able to pad our output with zeros if we'd like. Again, I'm just going to use the same named argument that I used previously, except I'm going to say I want to pad with zeros this time. And if we check our output, you can see right there how the white space was put previous to this, and here you can see where the zeros were transposed inside of there instead. So there's some ways that we can mess around with our data. Now let's look at some different math functions that are available to us inside of Rust. Now we're going to have all the basic mathematical functions that you're used to. So we'll be able, of course, to do addition inside of here. And then we just go 5 plus 4 outside of that. Likewise, we'd be able to do subtraction, multiplication, division, as well as modulus, which is going to give us the remainder of a division. And there you can see are all those answers to those basic mathematical functions that we have. Let's come in here and define another. This is going to be a mutable variable. and let's make it -4. Now you can define these data types in a couple different ways. Let's just make this -4 and say it's going to be a 32-bit int, like that. We could then, of course, come in here and output that information. Let's say we wanted to get the absolute value of -4. We could then put in our variable inside of there and then get the absolute value by finishing the variable with the actual function name. And you can see right there how that works. We could also come in and define the variable just like this and the data type along with it. And you can see right here, we can get 4 to the power of 6. We can calculate the square root. We can calculate the cube root. Round is going to round the value depending upon if this is a 5 or a 4. So if it's a 5, it's going to round up. If it's anything less than a 5, it's going to round down. Floor is going to always round down. Ceiling is always going to round up. We can get e to the power of whatever we put inside of our exponent. We can get our natural log, our base 10 log. We can convert 2 radians with 2 radians, or 2 degrees with 2 degrees. And here we can get whichever value is the maximum value by just first putting in a value or a variable name, followed by max and the value we want to compare to it. And we can do the same thing with min. And you can see the output from all of those other different calculations. So there's a whole host of different mathematical functions we have inside of Rust. And there's more, of course, that I won't even cover here. But of course, we're going to be able to also come in here and get the sign, if you would like to do that. So we can do sign, and 3.14 is equal to 3.14, and this is a floating 64-bit number. And to get the sign for that, just go in there and do that. We'd be able to equally also get the cosine, tangent, arc sine, arc cosine, arc tangent, and so forth and so on. So as you can see, a whole host of different mathematical functions inside of Rust. And now I want to take a quick look at conditionals. Now our different conditionals are going to be well aware to you. They're going to have not equal to, greater than, less than, greater than or equal to, as well as less than or equal to. And our logical operators are going to be and, or, and not. And I'm going to show you how all those work here. So let's go and create a variable first, and let's just call this age old is equal to 6. And we can use our if statements here to say age old, and if it is equal to 5 in that situation, we are going to output some information on the screen that is going to say go to kindergarten. Else if is quite simple. We're just going to use else if, nothing funky here like in other languages. And here we'll compare a couple different values using a logical operator. So we'll say age old is greater than 5, and then we'll throw and inside of here. Of course, both of these conditions are going to have to be true for this to come back as true. So we'll say less than or equal to 18. And in this situation, we're going to perform a little bit of math. So we'll say go to and change this to grade, and then follow that up with that. And then we can come in and go age old minus 5, and that's going to get us whatever the grade the person should go to. And we could also come in here and go age old and do another one. We'll say something like less than or equal to 25. And I'm just using this as an example, of course. I'm not saying somebody couldn't go to school if they were in a different age group, obviously. And then we could say go to college. And then finally, of course, we're going to be able to say else. And here we'll just say do what you want. And you can see go to grade 1 pops back. Now let's demonstrate some of the other different options we have for conditions. Let's use the not operator. And that is just going to convert all of our trues to falses and all our falses to trues. And just go like this, and true. Also, let's demonstrate the or operator. And this is just going to say true, false, and if one of them is going to be true, then it's going to give a result of true. And we can just perform that operation outside of here. And then finally, let's come in and do the not equals to. True, not equal to, false. And likewise, we can say true, not equal to, false, to get that output. Whoops, had a little error there. Make sure that you put in your curly brackets inside of here, otherwise it's not going to know what to put inside of there or what the point of that is. And there you can see all the results of that. Now there's no built-in ternary operator, but you can kind of make one. So let's say we wanted to do something like can vote, and we want to assign a different value depending upon a condition. So we could say something like age old, and if age old is greater than or equal to 18, then we want to assign a value of true to the variable can vote, and we can do it just like that. Else, if it comes back as false, we're going to assign a value of false to it. And of course, we're going to be able to come in there and output this information and throw can vote inside of there. And of course, don't forget to put your little equal sign in there. And if we execute that, you can see it comes back as a value of false. So like I said, a little rough overview of some conditionals and how we can use them inside of Rust. Now let's take a look at some brief examples on looping. Again, let's define a mutable value, and that's going to be x. And first I'm going to show you how loop works. Basically, loop doesn't have any conditions. You're going to have to put a condition to jump out of it. What I want to do here is I want to print out all even numbers. So I'm going to use an if statement here once again. I'm going to say if x modulus 2 comes back as being equal to 0, which means that it would be an even number. Well, then I want to come in and print that information on our screen. And let's just keep it simple, do that. And there's x, and it has to be mutable because we're going to be changing the value of x, of course. And one way you can, sort of a shortcut way you can increment the value of x is to do that right there. And then if I would no longer want to check anything, I can go continue, and what this is going to do is obviously increment x because I did it right there. And then this is going to jump and skip everything that follows after here and jump back to the top of the loop and check the value again. Now, how are we going to check these values? Well, first we checked if it was even or not. Now what we're going to do is figure out how we are going to jump out of this loop altogether. And I'm going to say if x at some point is greater than 10, well, I want to jump completely out of the loop, and break is going to do that for us. And otherwise, we're going to come down here and we're going to increment the value of x. Also, you can decrement the values in exactly the same way. And we can go and do a continue once again. And if we run that, you can see we printed out only the even numbers right there. We're also going to have while loops. Let's go and create another one here, and let's just call this y is equal to 1. And while loops are going to work in a similar fashion, except you're going to put the condition directly right after y. So I'm going to say while y is less than or equal to 10. I want to continue looping here, and I'll just keep this simple and throw that there. Throw your y right there. And then of course you're going to have to increment your value as you cycle through this. And there you can see it printed out 1 through 10. And then the final looping structure we have here, there's a couple other different ways to loop with for, but this is a basic way. What we're going to do here is work with a range. So it's going to be 1 through 10. And just to keep that real simple, I'm just going to come in here and do this. And we'll throw 4 inside of there just so you can see how that's different. Throw z inside of there. And there you can see all the loops and how it worked with the for loop and how we're going to be able to run through that. So we'll be doing more with looping as the tutorial continues, but there is a brief overview of the different options you have available to you. And now I'm going to take a closer look at strings. So we can come in here and define a string, and we'll just have this be I am a random string. Now we're going to be able to get our string length, and we'll just throw that in there, and we'll go random string and follow that up with len and output that information. We're also going to be able to split a string in half based off of a defined index. So here's where we're going to be assigning multiple values at once. So we'll say first and second, and then we'll go random string, and then we'll say that we want to split at a specific index, which is going to be 6, and then we'll be able to output that information. So we'll just say something like first and then second, and then first and second inside of here. And there you can see how those split out and exactly how they're lining up. And the reason that extra space is inside of there is because the extra space is inside of the string itself. We're also going to be able to create an iterator for our string. So let's go and call this count is equal to random string characters and count those characters. And then we'll go and create a mutable. Characters is going to be equal to random string characters, and then go and create another mutable to get our individual characters. And how we're going to get each individual character is by saying next each time. So we want to call next every time we want to get in the next character. We're going to use a loop here. Then we're going to use something called match, which is very similar to switch inside of other languages. And basically what we're going to do here is this is going to return either sum followed with an actual value. And if it does that, what we're going to do is we're going to say that we want to print out those individual characters. Just assign that to x. And otherwise, it is going to return none, which means that we no longer have any additional information to output on our screen. And after this, what we'll do is just go individual character and call for the next character. So we're going to continue cycling through characters as long as we have characters to display. Whoops, and we want to change this to characters, and then characters to this as well. And run that, and you'll see that it outputs all the individual characters as well as all the white space involved. We're also going to be able to split this information based off of white space. So let's go and create another iterator, and we'll go random string, and to split it white space, we go split white space. We'll go and create another mutable, which is going to be each individual word that we want, and then we'll go iterate next. And again, we will create a looping structure here to cycle through this. We're going to use match again. So this is going to allow us to cycle through this information. Once again, sum with the individual word that we're going to be using here is going to be returned. And then we can say that we want to output that on the screen, or it's going to return none, which means that we don't have any more words to work with. And let's throw a comma inside of there. And then otherwise, we're going to go individual word and say that we want the next word. And throw that outside of the match block. Oops, and change this to white space. Sorry about that. And run it, and now you can see it outputted all the individual words. We're also going to be able to iterate over lines of a string. So let's go and create one here. We'll just call this random string 2. And here what we're going to do is we're going to be outputting the lines, and we're going to separate those using a new line. So let's go mutable lines is equal to, this is going to be random string 2. And we'll call lines to get those individual lines of text. And to get our individual line, just go like this. And again, we're going to do the same thing, lines next. And then we're going to loop through those lines of text and then output them. And we're going to use match again, just like we did previously. So individual line this time. And just like we did previously, sum is going to return a match for us. And here we can output those individual matches. Otherwise, it's going to return none if there's no additional information to output on our screen. And if that happens, we want to break out of it. And of course, we're going to continue checking for additional lines outside of the match, but inside of the loop. And there you can see that we printed out those individual lines based off of the new line. We're also going to be able to come in here and find a string inside of a string. So let's just do something simple here. And let's say we want to find the word best inside of here. We'll just go random string 2, and we'll ask it if it contains the word best. And you can see that that comes back as true. And that is a basic overview of some ways we can work with strings. Of course, we're going to be covering them more in further examples, but now I want to show you a little bit more advanced application where we're going to receive input from the user, manipulate it, and then provide different information depending upon a number guessing game which we're going to create. So we're going to do a couple things here. We are first going to name our loop so that we will be able to jump out of it, and I'm going to call this outer, and this is going to be a looping structure. And it's going to start off by defining a number that is going to be the number that we want them to guess. And that's just going to be 10. I'm then going to ask them to pick a number. And then we're going to have another loop inside of here. And we're going to create a string. And we can go string new. We then want to pass a reference to where we want to store our string whenever it is input on our keyboard. And this guy up here, this is the input module we're using here, standard in. And this is just going to call that specific function for us. And we're going to read that input that they have here, and this is going to be a reference to said input. That's what the little and sign there means, that it's going to be a reference, and we're going to get more into that as we continue. Now let's do something a little bit more complex. Let's go and define our guess. Then we're going to say option, and this is a 32-bit integer. And an option value is either going to return some with a value, like you saw previously with match, or none. And we're going to say input and OK. And this means that the reader is at the end of the line of input. That's what it's going to check for. We're then going to follow that up with map or, which is going to apply a default value or apply functions to a value. So we're going to say none here. Or what we're going to do is come in and trim off the new line that was put inside of here. And then we're going to call parse, which is going to convert this string to a 32-bit integer for us. and then there is OK again. Whoops, make sure you put the OK on the outside of that. And then after we have converted that into something we can use, we can go all match and guess, and this is where the option part comes inside of here. We're going to be able to say if they don't have any information, well, we want to print a little warning that says enter a number. If they, however, did enter some information, we want to verify if it was matching our number that we wanted. We'll say if n is equal to the number we defined, that's the 10. Well, in that situation, we want to do a couple different things. We want to print out that they guessed the proper number. And then after that, we want to break completely out of our loop, which is going to be our outer loop, which we defined above. Remember, we put outer here with that loop, so we're going to jump completely out of the looping structure. And then let's cover some other potential issues. So let's say that they entered a number, but that number is going to be less than the number that we expected them to enter for us. So we're going to say print line, and we're going to tell them something like the number they entered was too low. Otherwise, let's go and throw another one in here. This is going to be too high. So if number is greater than the number that we have here, we're going to say too high. And then finally, we can handle any type of an error, underscore, and that guy right there comes from this guy right there. And that's going to, in that situation, we're going to say an error occurred. Whoops, and an error popped back, and we're going to get rid of that by getting rid of that semicolon and putting in a regular comma. And also up here, we want to make sure we put 2 colons inside of there instead of just 1. And for our print line, we want to come in here and put in our exclamation point. Sorry about that. And execute. We put 1 inside of there, 2, 3, 100. If we type in just enter and nothing, it's going to say enter a number. And if we type in 10, it's going to say you guessed it and jump completely out of the code. So there's a little bit more of an advanced explanation of how to use Rust. Now I'm going to jump over and provide some examples on how we can use arrays. Now an array is just going to be a fixed size list in which everything in the list is going to be of the same data type. And we can just throw some items inside of there. And we can get the array by our index, just going random array like this. And let's say we want the first item. This is a 0-based array. That's going to output that on the screen for us. We're also going to be able to get our array length, just like we did previously, just by coming in here and going len. And also, let's show you how to get a slice of an array. So for example, let's say we wanted to get the second 2 items in our array. Let's just go second 2. If we want to output an array, we're going to have to use this little guy right here, that colon with a question mark, and that's used for debugging this information. And here we are going to get a reference to our array, and then define a range we want. So we want the second 2, so we're going to say we want to start at index 1 and then go up to 3. And if we execute that, you can see right here that 1 is going to come back because we said we want the 0 index, and there's 1, length, there's 3 elements, and then right here we were able to get 2 and 3 by saying that we wanted the second 2 items inside of our array. So that's just the basics of arrays, and I leave it to you to go and check out the different functions that are available with arrays inside of Rust. There are a bunch of them. But I also want to focus in here now on vectors. Now, unlike arrays, a vector is going to be able to grow in size. So let's go and create a vector here. How we define them is go vec like that, and just like that, just similar to arrays anyway. And let's go and get the index. So let's say we want something like item 2 from our vector. This, of course, is going to change to vector 1. And we want the second item. Well, we'll just put in a 1 inside of there. We're also going to be able to iterate through arrays with for loops. So we can say for I in, and we're going to use a reference to our array. We're going to get more into how these references are used and why they're used. Just know that we're going to use those when we are not using primitive values, and primitive values are all these guys up here. Let's go and create this, and let's go and output vect colon, and I is going to get all those individual values. We don't need to do anything else with it. And we're also going to be able to push items onto our array, push items onto the end of our array, just by saying push and 6. And then we're going to be able to pop items off of our array or delete them from the end just by going pop. And let's get rid of this stray quote we have right there and run that, and you can see exactly how we're able to work with and cycle through vectors. Alright, so there's a brief overview of vectors. Now let's take a look at tuples. Now basically, tuples are fixed size lists of many different types, and instead of indexes, they are going to use keys. And you've probably seen them in other languages. So we'll say random tuple, and we'll say Derek and 40. You could also come in and define the data types that you want to use for your tuple. Let's go and create a new one called tuple2. And we're going to put a colon inside of there. And we're going to say that we want to use a string here. Again, it's not a primitive, so we have to put that reference inside of there. And then let's just throw the same information inside of here just to keep this nice and simple. We're going to be able to get the value from the index. So let's just go print line, and we'll say name is what we're looking for here. And this is going to be random tuple 2. And then if we want to get the 0 index for that, we can go 0.0. And there's our output. So again, once again, brief overview of tuples. Much more to find out. Just wanted to provide you with basic information. So now we're going to do something a little bit more complicated. We're going to start creating some functions. And you're going to create your functions down here outside of the main function. So I'm going to create a function. Again, I'm going to use fn. And this guy right here is just going to be say hello. It is going to receive an attribute of name. And you're going to have to define what type of attribute that's going to be. It's going to be a string. Again, it's not a primitive, so we're going to use a reference here. And this guy's just going to print out hello, followed by whatever name you passed inside of here. So we'll just throw name inside of there. And then we can call that just by saying say hello inside of the main function. And then we'll throw Derek inside of there. And when we execute, hello Derek pops back. So let's do something a little bit more complicated. Let's say that we want to receive 2 values and return 1 value. We're going to add these values. So we'll call this get sum, and we're going to get number 1. Again, we have to define what it is, 32-bit int, and num2. And this is going to be a 32-bit int as well. Going to then define what value you're going to be returning, which is going to be a 32-bit integer. And if you do not put a semicolon at the end of your function, this is going to be the value that you automatically return. So you don't always need to use return, but you can use return, as you'll see here in a moment. And then we'll be able to come in here and perform this addition. So let's say 5 plus 4 is equal to, and we can call our function upside here. So we'll say get sum, and it will pass in 5 and 4 as the attributes, and run it, and you can see that that works. Another thing that's kind of neat is we can create what's called a binding to a function. So we can say we want to define a variable called sum and then bind it to the getSum function, and then call this and execute it in much the same way. So we'll say 6 plus 4 is equal to, and then use sum instead of the actual function name. And with closures, you're going to see here in a moment that we're going to be able to do a similar thing with a whole bunch more, and also pass those functions inside of other functions. And there you can see is the result of that. And since we're talking about closures, why don't we go take a look at closures. Now, a closure is going to represent blocks of code, and they're going to be able to accept parameters and also be able to be passed into functions, just like any other variable. So let's create one. We'll say, call this sum nums. And then what you're going to do here is define a parameter that's going to be passed inside of it. And you're going to have the data type. So we'll say x and y. Both of them are going to be 32-bit integers. And then we're going to define exactly what we're going to do with those two values as they're passed in. We're then going to be able to come in and let's say 7 plus 8 is equal to. And then we can do sum nums and pass in 7 and 8. And that's going to perform that calculation for us, as you can see right there. Do something a little bit more complicated. Another thing that's kind of neat is we're going to be able to access variables that are outside of the closures. You can try doing this with functions and see that you're not able to do that, but with closures you can. So let's go and create a 10 variable here, and then create a closure that is going to receive a value of x, 32-bit integer, and it's just going to add whatever value is passed inside of there to num10, which is the variable that lies outside of the closure. And then we'll be able to come in and say 5 plus 10 is equal to, and then call our closure right here. So add 10 and pass 5 inside of there. And if we run it, you can see that that indeed works as well. So basic overview of closures. Now I'm going to talk more about ownership as well as pointers and why we have to use references. So basically, there's only going to be one binding for each resource that we have. And when I say resource, I'm talking about anything that's not a primitive value or a primitive variable inside of Rust. And what that means is if you assign data to another variable, the original can no longer access that data. So let me show you an example of what I'm talking about. So let's create a non-primitive. Let's create a vector, and vec 1, 2, and 3. And then let's go and create another vect. And let's assign the value of vector 1 to that. Now what I want to do is I want to print out the value here and see what happens. So we'll go print line, and I'm going to say specifically that I want to get the 0 index for that vector, and I'll put that on our screen. And if we come outside of here, this, you would think that that would work, but it does not. And this is the error you're going to see anytime you're trying to use something that you really should be using a reference, use of moved value. So that is an example of how you would have an error whenever you were trying to work with non-primitives. Now that doesn't work, but would we be able to do that with primitive values? Actually, you're going to see yes you can. So we'll say primitive value, and let's just give this a value of 1, and then we'll create another primitive value 2 and assign primitive value to it, and now try to print that information out. So we'll say prim value and then call prim value. And if you run it, you can see that you can access that. So primitive values you can access, but you're not going to be able to do that with vectors and anything. It's not a primitive value. So now what I want to do is come down here and create a function that's going to sum all the values of a vector. So we're going to say sum vex, and then we're going to call it v1, and we're going to define that it is a vector by putting our reference sign inside of there, and it's going to contain 32-bit values, and then it is going to return a 32-bit integer, and then we're going to define the sum of all those different values, and we're going to do that by creating an iterator that's going to cycle through all those different values. We're then going to call fold, and fold is an iterator adapter that's going to apply a function to all the values in this situation to our vector, and it's going to take an initial value, and that's going to be 0, and then it's going to contain a closure which is going to receive an accumulator and an actual element. So we'll say mutable sum is what we're going to be working with here, reference to x, and then the closure is going to be sum, and we're going to add all the incremental values of x as it cycles through our vector and store those in sum. And then, like I said before, you are able to use return inside of Rust, and we're going to return that sum. Now if we want to call this function up here, we're going to pass a reference to our vector. So we'll say print line, and we can say sum of vect. And then inside of this, we're going to say sum vex is the function we want to work with, and we're going to pass a reference to our vector, which is going to be perfectly fine. And this is going to be vector 2. So let's come in here and define that. Let vector 2 is equal to, and also we can come in here and pass this value inside of a print line statement. Let's just call this vect. Again, for debugging reasons, we're going to use the colon and the question mark and call vector 2. And you can see right here that not only were we able to pass that vector inside of the function, and also we were able to still print it out thereafter. So that's how we use references to pass data between different variables as well as different functions. So now let's take a look at structs. Now structs are going to be used to create custom data types. So let's say that we wanted to create, again we're going to do this outside of main. Let's say we want to define a circle data type that's going to be custom to us. And let's say we want to have an X point inside of it. We're going to have to define what type of data type. Also, we're going to have a Y, again, different type of data type. And then we'll have a radius because that's important with our circles and with some calculations we're going to be performing with our circles. So there we go. We created that. Now I'm going to show you a couple different ways to create functions that are going to be tied to our structs. The one way we can do it, which isn't considered to be the best way, is we can go and actually define a function directly. And again, we're going to be passing in a circle reference. And in this situation, we're going to be passing back 64-bit float. And to get that radius, for example, we just go circle radius, and that's going to return it to us. However, it's recommended that we define structs with the implementation operator instead. and that is IMPL. And we're going to say a circle here, and then inside of it define our function. So let's say we want a function that's just going to get the value of x. We could do so. We're going to have self here, which is going to be a reference to the circle object we are working with. 64-bit float is what it's going to return. And like I said, self is going to return to, or refer to the circle structure that we are creating inside of here. And now we can come up inside of here and create a circle. So let's go say this is mutable. Circle 1 is equal to, this is a circle struct. And then we'll define all the different parts. We'll say x and give that a value of 10, and y, give that a value also of 10. And then to keep it nice and simple, we will go and create a radius and also give that a value of 10. And then we'll close off this guy, and we can get our circle values. So let's go get rid of this. And inside of there, we're going to say that we want to return x, and we want to return y, and we want to return our radius and output all those on the screen. And then to reference them and get those different values, we're going to say circle 1 dot x and circle 1 once again dot y, and then circle 1 dot radius. And we'll be able to output those onto the screen. Likewise, we're going to be able to reference and get our radius using the function that we defined down below. So we're going to come in and do another print line and say that we want to get our circle radius. And then if we want to call that function directly, we can go get radius and then pass in a reference to the actual circle, and that'll return that to us. And likewise, we will be able to use the implementation function we created. And here we're just going to say circle x is the value we want to work with. And what we want to get out of it, we're going to say circle 1 and get x is the function we're specifically going to call. Compile and run. And you can see that we're able to get the radius and also get the value of x, and the different ways we were able to get that, either by defining this function directly or by using the implementation option that's available to us. Now we're going to also be able to use something called traits, which is going to define functionality that a type is going to provide. So let's come in here and let's create another struct, and this guy is going to be a rectangle, and a rectangle is going to have a height, which again 64-bit float, and a width, which is also going to be a 64-bit float. And you're going to use traits much like you use interfaces in other languages. So let's say that we want to calculate the area for both rectangles as well as circles. We're going to say has area, and then we're going to define a function. Area is going to receive the struct we're going to be working with here, our custom data type, and it's going to return a 64-bit result to us. And now we can implement that has interface for both of our structs. So we'll say implement has area for circle, and then define the exact way that the circles are going to implement this. So it's going to be past that object itself. It's going to return a 64-bit value, of course, and we'll just go 3.14159 and self radius times self radius is going to be the return value. And then similarly, we're going to do the same thing for our rectangle structs as area. So this is going to be rectangle. And then of course this is completely different. Here we'll say self and height times self width. Save that, and now we can come up here inside of main and play around with these different guys. So if we want to calculate our circle area, go in here and we'll say circle area. And to calculate it, we're just going to change this guy right here to area. And then likewise, let's go and create a rectangle using our custom struct we created. Let's just call this rect1 is equal to, and it is going to be a rectangle, and height as well as width. Close that off. And then in a very similar way, we're going to do the same thing here with our rectangle. So just paste that inside of there, and we'll say rect area. And then to get the rectangle area, we'll go rect1. And if we run it, you can see that indeed we were able to get our circle area as well as our rectangle area. So a whole lot of information there, and now I want to take a look at enumerated types to finish it off. Now an enumerated type is going to have one of several values. So we're going to create an enumerated type here, and we're going to call it hero. and we're going to say they can have a value of fast as well as a value of strong, and in that situation it's going to also contain a 32-bit integer. And also we'll be able to come in here and go info and define something like the superhero's name, which is a string, and the secret identity for our superhero, which is also going to be a string. We're then going to be able to define functions to work with these. So let's say we wanted to do something like get info, and this is going to receive a hero. We're going to use match again to perform different output depending upon what type of information we are receiving here. So we're going to say if we receive hero with fast, what we're going to say is we want to print some information out on our screen, and specifically we're just going to print the word fast out. Otherwise, if we receive hero with a strong attribute, we're going to get that value of I and use it in our output. So print line, and we'll say something like lifts whatever number of tons. Or if we're using info, we're going to get the name as well as the secret identity for our hero, and we're going to print that different information out here on the screen and then get the name and the secret identity for our hero. Throw in that little colon there, and now we'll be able to jump up inside of main and actually define these guys. So let's define the vjFaLk, and he is going to be a hero that is going to be strong. Now remember, it receives an integer, so there that is. Could also come in and go Quicksilver, and he's going to be a hero that is going to be fast. And then finally, we can go and define Spider-Man and give away his secret identity with info. And here we'll pass in name, which is going to be his personal or his name, whatever, his superhero name. And we're going to have to, however, convert this from a string literal into a regular string. And to do that, we go to owned. And then likewise, we can come in and go and define his secret identity, which is going to be Peter Parker, to owned, close that off, and then we'll be able to call our getInfo function that we defined, pass in vjFaLk, and also get info, and pass in Spider-Man to see the different results we get. And whoops, put tons right here, and it's supposed to be outside of that area, so we'll just go like this, get rid of that, and throw tons inside of there. And if we run it, you can see that the vjFaLk is going to lift 100 tons and Spider-Man is Peter Parker. So there you go, guys. That is a rough overview of Rust, an introduction anyway. Hope it helps a lot of guys out there because I know there are no books on Rust and the documentation is considered kind of weak. So hopefully I helped you guys out there understand the language better so you can move on from here. And like always, please leave your questions and comments below. Otherwise, till next time.